Okay, so I'm going to go through electron configurations and orbital diagrams. It may take a little longer than normal. All right, it's not going to be terribly short. And use my iPad. I guess I'm just going to kind of pretend like, or make the assumption that you don't know anything. All right. And shoot, I believe you're seeing my iPad, right? I want to make sure. This is to go away. Okay, that needs to go away. Okay, let's make that go away. All right, so electron configurations. Basically, what you want to think about is we are configuring the location of all of an element's electrons, all right? Let's talk about electrons. You know, they're tiny little speedy particles that are flying around the nucleus. They are located in orbitals. Orbitals have different shapes and are located on energy levels outside of the nucleus, right? This is your little positive nucleus. It's positive, and you can envision energy levels as such, even though it is incorrectly, it's not the way this is really happening. However, it does not inhibit your understanding, in my opinion, to kind of visualize energy levels as such. This being the first energy level, the second, and the third. So we would call this N equals 1. We would call this N equals 2. And we would call this N equals 3. And there are actually a total of 7 energy levels. Okay, so we would do this 7 times, but we don't need to do that. There's 4, we can. There's 5, there's 6, and there's 7. Okay, so we don't have space to do all of that. All right, and what you see here, and this is going to take a while because I'm actually going to knock a lot of things out in this one video. What you see here is that, 4, oops, that's 5, that's 6, and that's 7. What you see here is obviously N, right? The letter N stands for energy level. It is a symbol for energy level. And you see that as N, the energy level increases, the distance from the nucleus increases, all right? I mean, it's obvious, but it's important as well. And we'll see why as we proceed through this, the rest of this unit about atoms. So it's the distance from the nucleus increases. Now, all right, I'm not going to go too much, but that's important because we're going to talk about the attraction of electrons to the nucleus. So that distance is important. Okay, but we're just going to focus on electron configurations, Ms. Murphy. So let's stay on topic. Let's stay on the agenda. An electron configuration configures the location of electrons. All right, it's like writing an address for where all of an atom's electrons live. So we would first talk about our energy levels. Okay, and we see that that is denoted by the letter N, and there are 1 through 7 of them. Okay, we could also we need to learn to visualize this with our periodic table. Okay, so you're going to see me referencing this periodic table quite often. And what you need to realize is there is 1, 2, 3, 4, 5, 6, 7 periods, right? Periods go across. There are 7 periods on the periodic table. Rows are vertical. That's not a row, that's like a column. A column is a group. That's what I wanted to say. Groups are vertical. And you need to know that. It's simple. But when we're referencing a period, we're talking about left to right. When we're referencing a group, we're talking referencing top to bottom. Okay, so there are 7 energy levels and there are 7 periods. You may be thinking about these. This is actually this part of row 4, and this is part of row 5. All right, don't worry about it. Cheers. Very rare. We're not going to be dealing with elements from down there. Okay. So what we'll see is that the electron configuration will actually reference elements in different rows of the periodic table. Okay, so this is like what street you live on, right? Do you live on the first street? Do you live on the second? Do you live on the third, right? It tells you which street. And those streets, which are really energy levels, guys, and you need to understand the vocabulary here. So if you don't understand a word I'm using, it is really important that you ask me about that particular word. But you could envision these different streets. Oops, let's not do that. These different streets, right? Going from left to right, right? This would be like street 1 would relate to energy level 1. All right, and this is important. That's why I'm not rushing through this video. Street 2 would relate to energy level 2. And I don't need to keep going because you should see what Miss Murphy's talking about. Street 3 would relate to energy level 3. And that would continue. So we see that, okay, let's keep going, stay on agenda. Well, remember, we're talking about electron configurations, and we're going to configure where electrons are located. I have to go around the block to get to the answer so that you understand. Okay, so the energy level would kind of tell you what street the electron lives on. Within streets, we have subshells, okay? Subshells. And so you could kind of envision that tells you what type of house you live in. There are 4 of them. There is an S subshell, all right? There is a P subshell. There is a D subshell. And there is an F subshell, okay? Subshells, and students get really confused. That's why I'm going very slowly and I'm writing a lot. Subshells contain orbitals, okay? And electrons are located in those orbitals. Now, when it comes to AP Chem, it is this concept that we will be discussing for a while is typically in free response questions, and you have to be able to write about it. And students across the country have a very hard time correctly writing about this. That's why I'm being very particular. Okay. Only 2 electrons are allowed in an orbital, right? It's like a bedroom, and only 2 electrons are allowed to stay there. Okay, let's go back up. So we talk about which energy level is the electron on. And then we talk about what subshell. Subshells are parts of energy levels, all right? These are parts of energy levels. So we're going from very broad, the energy level, to what part of the energy level. And then within that energy level, what orbital are you in? So it goes from broad energy level, okay? And then in that energy level, what subshell are you on or in? And then within that subshell, what orbital are you located in? Okay? Orbitals are regions in space around the nucleus that contain electrons. Now, if we go back to our periodic table, nope. I'm just thinking. Okay, S subshells contain 1 orbital, right? So if you live in an S subshell on the first energy level, then there's only 1 orbital. So it's like you live on this street, you live in this type of house, and there's only 1 bedroom in it. You can't see me moving my pen. You live on the first energy level, right? This is my analogy. You live on the first street. Can you see that? No, you can't see that color. You live on the first street. You live in an S subshell, and you live in this orbital, okay? I know I'm going around the block to get there, but I'm going to keep going. A P subshell has 3 orbitals, right? So there's 3 bedrooms in a P subshell, but they're really orbitals. They're regions in space. There's 3 regions in space where you could find electrons. The D subshell has 5 orbitals. And for an F subshell, you've got 7 orbitals, okay? Okay, now down here, we said that there's only 2 electrons are allowed in an orbital. So we have 2 equals 2 electrons max, right? What does that mean? That means an S orbital on the S subshell, you can only have a maximum of 2 electrons because there's only 1 orbital and only 2 electrons are allowed in an orbital. On the P subshell, we can have a maximum of 6 electrons, okay? Because there are 3 orbitals in the P subshell, and each orbital can have 2 electrons, so it's maximum of 6, right? Now, in a D subshell, there's actually 5 orbitals. There's 5 regions in space around the nucleus that you can find electrons. Therefore, in a D subshell, we can have a maximum of 10 electrons. And lastly, for the S subshell, which has 7 orbitals, 7 regions in space around the nucleus that can hold electrons, or electrons can be found, so we can have a maximum of 14 electrons, right? That's like a negative, E negative, and then an S because it's plural. So this is just an abbreviation for electrons, okay? All right, now that's the kind of the background. I kind of want to go through it. No, I'll save that. So let's look at, well, how we would apply that. Let's write the electron configuration. So we're going to configure where all of the electrons are located, and let's do that for chlorine, okay? Let's do this for chlorine. And when I look on the periodic table, I see chlorine. It's the element number 17. All right. So that means as an atom, right, it's got 17 electrons. Those are negative, right? He's got 17 electrons because he's neutral. So he's got 17, the same number of electrons as protons. So electrons always occupy the lowest energy level first. All right. And there's a rule for that. And I want you to think about it as you write it. Electrons always occupy the lowest energy levels possible. Okay, that means they like to be as close to the nucleus as possible, right? Now, they don't have preferences like when I say like, but so it's really an issue of energy, right? And potential energy. They like to have a distance from the nucleus that would minimize that potential energy. And they are most stable. So stable is the word I'm looking for. They're most stable at a distance at closer distances to the nucleus, right? Because there's an attraction between the positive nucleus and the negative electrons. All right. And you're going to find those electrons as close to the nucleus as possible. All right. And we call that the ground state. The electrons are as close to the nucleus as possible. They're where you expect to find them. So we always follow something called the Aufbau sequence when determining where electrons are located. And I happen to memorize the Aufbau sequence, okay? And it is utterly connected to the periodic table, right? I told y'all this would be a long video. It's utterly connected to the periodic table. So when we look at the periodic table, we need to see it in terms of blocks, okay? I know we'll get back to the chlorine in a minute. I realize there's information missing. We must talk about the periodic table. And we have to see it in terms of blocks, right? Where these first two columns are the S block. Over here, the last 6 are the P block. And the center, the transition metals, the D, and then down here we have the F block. Remember, we had already numbered it 1, 2, 3, 4, 5, 6, 7, 4, 5, okay? We have picked an element, chlorine. Chlorine lives right over here, right? Chlorine lives right here. He is element number 17. So in determining the electron configuration, I'm literally going to just look at my periodic table and I'm going to begin writing the configuration. And this is what we would do in class. I would give you a blank periodic table and we would do this together. Now, mine is probably not to scale, so you're going to have to bear with me. I wish I actually had a picture of an actual periodic table right here with me. I need to insert one. I had done that. I don't know where it went. Is it back here? No. Do I want to get to it? It's right here, actually. All notes, periodic table. Boom. Can I write on it? Boom. Okay. Can I write on it? Yes. This is perfect. Okay. So chlorine, people, is right here. Look, they've already got it numbered 1, 2, 3, 4, 5, 6, 7. So I'm going to go to the first energy level, right? I'm always going to start here. And I'm going, so here's my electron configuration. Oops, don't do that. I'm at the first energy level. So I'm going to write a 1, right? 1. Stop, computer. Just my thing is messing with me. I'm gonna write a 1. Goodness. It wants me to type. I want to write. And this is not good. Can I write? Okay, I'll just write right here. I'm gonna write a 1, and that's for first energy level. And remember, I'm in the S. This is P. This is D, and F is down below. I'm not concerned with F. I'm in the first energy level. I'm in an S subshell, and an S subshell can hold 2 electrons. So I'm going to put 1 electron there. And notice helium is atomic number 2. You could imagine helium being right here. So I'm going to put 2 electrons, 1, 2, envision those as electrons, in an S subshell on the first energy level. So helium's gone, right? You can imagine him right there, but we'll leave him over there. Helium's gone. We've gotten rid of 2 electrons. Remember, chlorine has 17 electrons. So we have 15 more electrons to go. All right. Well, I'm going to take those electrons, and I'm now going to put them on, they're going to go on the second energy level. So I'll write a 2 for second energy level. I'm in the S subshell. That's 1, 2. So I'll go S subshell. I can put 2 electrons there. Now I'm going to move over here, and I'm still on the second energy level, but I'm entering the P orbitals. So I'm going to put 1, 2, 3, 4, 5, 6 of my 17 electrons are going to still be on the second energy level. They're going to be in P orbitals. And P, there are 3 P orbitals. Each can hold 2 electrons. That was in our notes. So we can put a maximum of 6 electrons there. Okay, now I'm going to continue reading my periodic table like a book. I'm going to come back down here. I'm now entering the third energy level. So I'm going to write 3. And I'm in the S orbitals. I'm going to write S. And I've got 1, 2 electrons, maximum of 2 electrons in the S orbitals. And these are on the third energy level, and S orbitals on the third energy level. I'm going to keep reading this like a book. I'm going to get to aluminum, and I'm going to go 1, 2, 3, 4, 5. And I got to chlorine because that was, we're doing the electron configuration for chlorine. So I'm going to stop, right? So I'm on the third energy level. I'm in P orbitals, and I have put 5 electrons there. So the electron configuration for chlorine is this right here. What does it mean? It means that there are 2 electrons in S orbitals on the first energy level. There are 2 electrons in S orbitals, in the S orbital actually, on the second energy level. There's only 1 S orbital. There are 6 electrons in P orbitals on the second energy level. There's 2 electrons in the S orbital that's on the third energy level. And there are 5 electrons in the P orbitals on the third energy level. All right, let's clear this up. And let's do another one. All right. And you need to pay attention because I'm going to give you one that's in the D block. Remember, this is S, this is P, this is D. Now, we have not said this yet, but there's something that says DN minus 1. Okay? So what does that mean? And let's do this, guys. Let's go 1. Let's look at this a different way. If you're confused, if not, if you know all this, guys, just fast forward, right? If you understand the D block is N minus 1, and you totally understand that this is 4S2, 3D4, and if I said, who is 5P5, and you went 5P5, if you went right there, and you know that, and if I said, who is 3D10, and you went right there, you're good, okay? You need to fast forward. But some of you, if you have no idea what I was just talking about, you need to keep watching this video and don't fast forward. So you need to see this as 1s, and helium is actually a part of that, okay? You need to see this as 2s, read across here. This is 2p. Read all the way through. You need to see this as 3s, read all the way through to 3p. Don't leave me yet. This is 4s. Now I'm in the D block, right? Right here, I'm entering the D block. The D block, I'm going to write it again, is n minus 1. All right? So if n, these are my n values, 1, 2, 3, 4. So 4 minus 1 is 3. This is 3d. I read through, I'm back at 4p. Read through to 5s. Now I'm in the D block, it's 4d, 5p. 6s, we actually go down to the 4f, and then this takes us to 5d, 6p. 7s, down to 6f. Don't worry about it. We won't deal with it. But this is 6d, and this is 7p. Okay? So let's do the configuration for arsenic, atomic number 33. So that means I have 33 electrons, and I need to detail where every single one of them is located. So I'm going to change my color. Let's do blue. And let's start canceling these off. Now, guys, I can do this really fast, but I'm going to do it slow. So I'm going to go to the 1s. I'm going to put 2 electrons there. Remember, s can only hold 2. That takes me through this because helium is over, right? Just don't worry about it. Just take it. Right now we're on 2s. 2s. I'm going to put 2 electrons in that s subshell. And I'm going to read across, and now I'm at 2p. 1, 2, 3, 4, 5, 6. It can hold 6. I have 6. Let's put 6 there. Now I'm going to come down to 3s. 1, 2, and I'm going to write it. 3s2. Read across. That takes me to 3p. 1, 2, 3, 4, 5, 6. 3p6. All right. That takes me to 4s. 1, 2, 4s2. And then, oh, look here. D block. 3D. 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 3D 10. And now I'm back to 4P. 4P, 1, 2, 3. You can hold 6. I only have 3. So I will put 3 there. All right? And this would be the electron configuration for arsenic. Atomic number 33. It tells you where all the electrons are located. I'm going to go back to my note here. All right, let's go back here. And now let's go back to the periodic table because you need to understand some things, like some of the things I was talking about earlier. So what you need to realize, first of all, is that arsenic looked like this. Well, let's look at chlorine. Chlorine looked like this. 1s2, 2s2, 2p6, 3s2, 3p5. That was chlorine, okay? Now, chlorine, let's write this in your notes. We need to write valence electrons, right? Well, what are your valence electrons? They are the electrons on the outermost energy level. Okay, they're the electrons that participate in bonding, right? They are on the outermost energy level. Well, you need to realize that in your configuration, these numbers right here represent your energy levels, okay? So we see that we've got 3 energy levels represented. For chlorine, the outermost energy level is the 3rd right here, right? That is the highest number. Therefore, that is the most outer energy level. It's furthest from the nucleus. And we see that on that energy level, there are 7 electrons. So what that tells us is that chlorine has 5 plus 2, 7 valence electrons, because there are 7 on that outermost energy level. Now let's keep that in mind, and let's look at the periodic table. And let's see how those numbers relate to chlorine's location in the periodic table itself. All right, it's really pretty cool. It's really pretty cool. So here's chlorine. Well, what I notice is that chlorine lives on the 3rd period, right? Well, that happens to also be the location of his valence electrons, right? We've already identified that it's the 3rd energy level. So what that means, and it's true for every element with the exception of the D block, it's not true, is that we call the S block guys and the P block the representative elements, because what I'm telling you now is true for those elements. Okay? So what I'm telling you now is true for S block and P block elements. And what I'm telling you is that the period, and you should be writing this down, that the element is located in on the periodic table, the period number, so for carbon, that's 2, for silicon, that's 3, for bismuth, that's 6, okay? The period number tells me the location, and by terms of location, I mean the energy level. That's what you really should say, okay? You should be writing energy level, and you should use that term and not look, but what I'm using the word location so that you'll understand of the valence electrons. So if I look at what period an S block or a P block element is located on, that tells me the energy level that the valence electrons are located on, okay? Very important that you realize that. The other thing that I notice, and I only notice it if I number my groups, remember groups go up and down. I only notice this if I number them in a particular way. And that's if we number them, let's get a better color that you'll see, green. If I number them, not 1, 2, 3, 4, 5, 6, 7, 8, not like that, but if I number them 1, basically, guys, I'm just going to number those representative elements, the S and the P block. 1, 2, 3, 4, 5, 6, 7, 8. Then, and these are now group numbers. What I see, right, is that the group number for an S and or a P block element, you should be writing this down, the group number, and that's 1 through 8, right? For the S and P block elements, right? I can't write all this, but the group number is equal to, I'm going to erase my 8 right here. The group number for the S and P block elements is equal to the number of valence electrons, right? So what we just learned is that the period number tells you what energy level the valence electrons are located on, and the group number tells you how many valence electrons are there. Okay, so notice that chlorine has 2 plus 5 7-valence electrons. So we should expect to find him in the 7th group. And in fact, he's right here in group number 7, right? That is group number 7. 1, 2, 3, 4, 5, 6, 7, and 8. All right, I know that's messy, but that's just the way it goes. Okay, so if I was to say to you, whatever your name is, you know, there's a lot of you names are going through there. Ian, right? Sharon, Maria, Ansley, Abby, Adriana, Anna, Annika, Christopher. I'm going to miss some of you. I got to stop. Right, Denny. What element has 4 valence electrons on the 5th energy level? You'd go, okay, well, 4 valence. Everyone here has 1. Everyone here has 2. Everyone here has 3 valence, 4 valence. Okay, so this is one of these elements here. Let me clean up my screen for you, right? This is clearly going to be one of these elements because that's the 4th group, and they're on the 5th energy level. So I'm going to go 1, 2, 3, 4, 5. That would be 10, right? This element has 4 valence electrons on the 5th energy level. You see how easy that is? So I know immediately that sulfur has 6 valence electrons and they are on the 3rd energy level. And I know that barium has 2 valence electrons on the 6th energy level. So it's really actually pretty cool. Okay, and that was a long video, but that's what I have to do to teach you the electron configurations. All right, so I'm look horrible today. Sorry, guys. You got to figure it out. You got to do the work, make sure you understand it, and ask your questions. All right, I'm going to stop this video. This is bad. See you.